Hey guys, I want to edit here video 2 from section 4.2. Here we're trying to use the first derivative test to locate all relative extrema. So to find the derivative, first I rewrite this as a power. 2/3 multiplied by 3 is 2. Subtracting 1 from that exponent, x to the negative 1/3. Negative 1/3 times 12 is positive 4, and negative 1/3 minus 3 over 3 is negative 4/3. That's a negative 4/3. So in order to rewrite this, I wrote it over positive exponents. And then in order to get a common denominator of x to the 4/3, I had to multiply this term times x to make this denominator x to the 4/3. So I have 2x plus 4 over x to the 4/3. Now, remember to find our critical values. Not only do we need to find when our numerator is equal to 0, but also when our derivative is undefined or when the denominator equals 0. So we actually have two critical values here, one at x equals -2 and one at x equals 0. So now I can check these signs of f derivative to see where I'm increasing or decreasing. So greater than 1, greater than 0, I can plug in 1. 2 plus 4 is a positive over a positive. So this is a positive, so that means it's increasing. And notice it does not exist here. So I'm going to put an asymptote here, and we know it's 0 there. So now, between 0 and -2, I can check -1. Let's see. My numerator would be -2 plus 4, which is a positive. And then this denominator would also be a positive, so that makes us positive. So it's increasing. And then less than -2, I could pick maybe -4. That would make my numerator negative and my denominator positive. So this is negative, so this is decreasing. So therefore, this value or this function is increasing from -2 to 0, union 0 to infinity. Notice I included the -2 because it's 0 at that point, but I don't include 0 because it does not exist at that point. It's decreasing from -infinity to -2. And we can have a relative minimum at x equals -2 because it's increasing and then decreasing. So then if I wanted to find my minimum value, it's at f of -2, whatever that value is. So keep in mind when you're checking for critical values of non-continuous functions, derivatives, you also must set the denominator equal to 0 to find those critical values. And if your sign changes from decreasing to increasing, that means there's a relative minimum at that x value, and that minimum value is your function evaluated there.